Smartphone manufacturers have claimed for years that their devices can rival professional mirrorless cameras. Now, the Vivo X300 Ultra introduces a hardware architecture that attempts to make that claim a physical reality. Professional mirrorless systems derive their capabilities from strict physical properties, massive sensor planes capturing light, and heavy interchangeable prime lenses directing it. Conversely, a mobile chassis has severe space limitations. A device less than 10 millimeters thick simply lacks the Z-axis depth to house long focal lengths or massive sensor arrays. To compensate for this lack of space, the mobile industry leaned heavily into computational photography. They used software algorithms to digitally filter images and artificially replicate the depth of field that large glass creates naturally. The Vivo X300 Ultra breaks from this software-first mindset. Instead of relying on algorithms, it achieves its results through a brute force approach, packing a multi-prime sensor array and a professional-grade video encoding pipeline directly into the phone's body. To see if this actually works, we need to map the device's exact specifications against a standard mirrorless hardware pipeline. The X300 Ultra's design assumes that mobile video quality is best improved by expanding the physical footprint of the hardware rather than the concavity of the software. Before light hits a lens, we must examine the internal processing foundation. Moving massive professional video data requires serious bandwidth. The pipeline starts with the Snapdragon 8 Elite Gen 5 chip and its image signal processor, continuously ingesting heavy optical data without dropping frames. To prevent bottlenecks, 16 gigabytes of onboard RAM act as a high-speed buffer, holding that heavy data in active memory during real-time video rendering. Processing dense, uncompressed video at this volume creates extreme thermal output and drains power at an accelerated rate. Vivo mitigates this power draw with a 6,000 mAh Blue Volt battery, supported by 100-watt wired charging to keep the system fueled during prolonged shoots. The best glass in the world is useless if the camera overheats or lacks. This internal logic bandwidth and battery physics provide the necessary foundation to process raw optical data. With the processing foundation set, we move up the pipeline to the primary optical intake point, the 35mm documentary camera. This diagram shows the surface area of standard mobile sensors. The X300 Ultra replaces this with the Sony Leitia 901. It has a massive 1/1.12-inch footprint, capturing significantly more area than its predecessors. The larger the sensor, the more physical space to gather photons. This increased photon capacity directly yields a higher natural dynamic range, allowing the camera to retain detail in both deep shadows and bright highlights simultaneously. The Leitia 901 captures this light across a highly dense 200-megapixel resolution. At 35 millimeters, this combination of size and resolution closely replicates the natural field of view and depth perception of the human eye. By capturing more actual light, the hardware inherently reduces digital noise. It produces a naturally cleaner image without requiring aggressive software smoothing. Increasing the sensor's physical footprint reduces the reliance on digital gain, allowing the primary camera to capture a level of detail typically reserved for standalone mirrorless sensors. This chart shows the traditional flagship mobile architecture. It features one massive central sensor, flanked by two inferior secondary lenses. Vivo abandons this for a multi-prime architecture, elevating the secondary lenses to the same performance tier as the primary. Let's examine the 85mm periscope telephoto configuration first. This telephoto lens is backed by its own 200-megapixel sensor, completely matching the primary camera's pixel density. Shooting video at an 85mm focal length introduces a physical problem. Any minor movement is magnified, creating microjitter and motion blur. To solve this, the housing utilizes gimbal-grade mechanical stabilization at a wide f2.67 aperture, physically tilting to counteract hand movement and keeping the shot steady. Finally, the 14mm ultra-wide lens. It packs a 50-megapixel Leitia 818, capturing a sweeping 116-degree field. Because it uses a high-end dedicated sensor, it successfully eliminates the soft edges and optical distortion that normally ruin ultra-wide mobile shots. All three rear lenses utilize large format sensors and dedicated optics, classifying them as true high-performance prime equivalents. This multi-prime architecture means you no longer suffer a drop in quality when switching focal lengths mid-shoot. The optical density remains consistent across the entire array. Once the physical light is successfully captured, that data rapidly moves to the final stage, the video encoding pipeline. The internal processing power allows the device to record 4K video at 120 frames per second smoothly across all three of the rear sensors. Importantly, it supports 10-bit log video recording. Standard cameras aggressively compress data upon capture, but 10-bit log outputs a mathematically flat profile, preserving maximum dynamic range for editing. For immediate results, real-time lookup tables apply professional color grades directly to flat footage on the fly. It also includes full support for Dolby Vision output. And for absolute optical reach, Vivo introduced hardware modularity in the form of the Gen 2 Ultra telephoto extenders. By locking these external lenses onto the chassis, the optical pipeline extends out to a 400mm focal equivalent. Sustaining a system like this requires long-term software support. Vivo's Origin OS 6 provides the framework, backed by a commitment to 5 years of operating system upgrades and 7 years of security patches. The entire array is protected by a strict IP69 durability rating, sealing the delicate optics against extreme environmental hazards. By combining a multi-prime optical array with professional log encoding and physical modularity, the Vivo X300 Ultra successfully condenses a dedicated mirrorless pipeline into a single pocketable chassis.